This TMR the Math Wizard video for the first time is being filmed before a live studio audience. And mask. It's also our first mask video, so if I have to rob a bank after this video, I'm already equipped for that as well. But the first 2 days of Trig are basically here to wake you back up. Generally speaking, we're in school trying to use math parts of your brain that have not been used since like June of last year. This is even weirder this year because there are things, March sort of changed our lives. But neither of these days are foundational for the year. So if you don't like dominate the first 2 days, these are not things we're building on. These are 2 days worth of, I do these essentially because they're there in the book, and I think they're 2 nice little tune-ups for getting your brain going again. Friday will be the first lesson that's sort of foundational that we'll build from. I don't do 1-1 first. I'm going to do 1-1 tomorrow because 1-1 will go better with a calculator. The 1-1 is going to more wake up the part of your brain that does the numbery part of math. 7 times 6 plus 3, make your brain do that again, or have a calculator help you. So we'll do that tomorrow after you've filled out a permission slip and have a calculator maybe in your hand, and that'll be helpful for tomorrow. Today is more the math part of your brain that thinks and tries to process things. So I will grab my notes and just start putting things up on the board. So we're in 1-2. 1-2 is about a thing called mathematical models. When I turn and talk, can you still hear me? In mask world? Yeah. Okay. So mathematical models describe real situations. And they're used to make predictions sometimes. Shock malfunctionality. People are doing this right now all the time with COVID, okay? So you can't always trust mathematical models, but people are doing their best to try to make predictions. There's a lot of articles that'll be around that say, because of wearing masks, we've saved 70,000 lives, or 70 million lives, or whatever they'll say. Or if we go back to school, we're expecting this to happen, this many positive tests, or this many hospitalizations, or whatever. Those are all people that have taken information and tried to describe a real situation with math, and they're trying to make predictions. And a lot of those are flawed models at some level, but they're giving it their best shot. Weather prediction is like this. Weather prediction is based on math. That's a real situation. And the weather people try to make predictions of whether it's going to rain or not, and they'll give you their percentage chances. And sometimes they get it, and sometimes they don't. We like to make fun of the weather people like they're always wrong. They're right a lot too. You know, they're predicting the high today to be 81. It's easy for us to be like, oh, I don't know what they're doing. It was 83. Well, that was still a pretty good prediction. I mean, that all told. We're trying to do a very primitive version of this, and today it's going to be involving graphs. And it's not going to be graph paper graphs. It's just going to be some little like picture-y graphs. But before I do that, there's a thing called periodic functions. Those are things that repeat patterns. So some of the homework questions, I think all the homework questions, they'll ask you to make a graph and then decide if it's periodic or not. Periodic just means it repeats. So if it repeats some sort of a pattern, it's periodic. If it doesn't, it's not. That's just one of the words of the day. So we've seen this before for making graphs. Somebody tell me something on this graph that I could label. Yes?
1,
See?
Oh wait, oh never mind. Okay, quadrant 1.
Okay, quadrant 1, where's quadrant 1?
In the top left.
This
Oh, right. Oh my goodness.
So that's quadrant 1. Almost every graph today that you make is going to be exclusively in quadrant 1. So instead of doing this kind of a graph, I'm going to just ask you to do the quadrant 1 part. So something more like that. And if you forget the arrowheads, life goes on. Before we name some other parts, can anybody tell me what's special about quadrant 1 and why you think that's going to be this quadrant of the day?
It's all positive.
Everything's positive there. So we're going to deal with stories today that are almost all, exclusively positive numbers. So we can get away with just a quadrant 1 picture. Somebody else label me another part?
The y-axis.
Y-axis, where is that? That is this way. So that is the y-axis. This is often called the dependent variable. That's a word that if you have an unbelievable memory, you might remember me having said that before. You should all remember the y-axis because you've heard that a million times. To call that the dependent variable hasn't come up a lot, so you might have had that fade on you, but that's going to matter today that that's the dependent variable. Another thing? X-axis, that's got to be the other one. And that is called the independent variable. Small algebra 2 flashback. You might remember me giving you an equation like that and asking you to graph it. Frequently, the way you would do that, one way we had to do that is make ourselves a table where you pick the x's. Those were independent. Like you picked them out of nowhere. You could pick any number you want, independent of anything else. But then you plug those in. 0 squared plus 3, 1 squared plus 3, 2 squared plus 3. The y's you got depended on what you put in. Like, so the y's have always been called the dependent variable because they depend on what you put in. And the x's were kind of like, pick whatever you want, but we were pretty boring. We always pretty much went 0, 1, 2. Do some nice little numbers. Other parts we could label?
The origin.
Origin. So right there we have an origin. And then let's label our other quadrants just for the heck of it. Where's 2?
To the left.
To the left. So 2, 3, 4. If I touch, well, let's try this too. If I wanted to specify a location on that coordinate system, how would I do that? If I wanted to head you to a certain, I want to be right there-ish. How could I know and you know we were going there? How could I name you that location? Ordered pairs is correct. So ordered pairs, or things like that, where we go 2 numbers. I don't know, make up a pair of numbers for me that would be reasonable for that spot.
2 and 1.
What did you say?
2 and 1.
2, 1 maybe, yeah, sure. So that's like over farther than it's up, so maybe something like 2, 1 is where that could be. They'll tell you stories, and we're going to try to make a graph, and we'll get to a story in a minute. But let's first try like 2 more questions. If I touched the y-axis, what would that mean about the ordered pair? What would you know if I said I'm picturing a point that's touching the y-axis?
X equals 0.
That x equals 0. If the x is 0, that means you're touching the y. What would it mean if we were touching the x?
The y is 0.
The y would be 0. That's going to be a consideration we're going to try to make for the stories that we're about to read, hear, listen to. I think question 1 to ask yourself is, could this thing be negative that is being described? Could this thing be 0 that's being described? And the answer to this, based on what I've already said, is probably yes or no. Are the things that I'm about to describe going to be negatives?
No.
Probably no, because I already told you pretty much everything's going to be graphed only in quadrant 1. Could your things be 0? I'm going to say that's more of a maybe. Maybe yes, maybe no. But then beyond that, we'll try to figure out. If one of them's higher, that might make the other one be lower. Or if one's higher, it make the other one be higher. Some things go together in different ways like that. So if I said, like, you're studying for your trig test, we could measure the time you studied and measure your grade. If one of them went higher, you'd kind of expect the other one
to
go higher. We could measure how many cups of hot chocolate you sell based on the temperature. So if the temperature goes,
lower,
the sales go.
higher.
You know, she works at Rita's. You could probably measure Rita's sales based on temperature. When the temperature goes higher, the sales go
Higher.
So we're trying to think like that a little bit. Like one's going up, what would that do for us? So here's my first story for you, is that, I'll just use this space. The time it takes you to get home from school depends on your speed that you drive. That's true. So first question I'd ask myself is, what should go where on these axes? So they're going to be phrased to you in such a way that one thing is dependent on the other. So who is the dependent one? Time. Because it said time depends on
Speed.
speed. So I would do that first. I'd figure out what are my two things I'm measuring. One of them's going to go on the y, that's the independent, or the dependent. One of them's going on x, that's the independent. And then consider, can I have a negative time? And the answer to that is probably, for all of the stories, going to be no. But consider it anyway. Can you get home in a negative time? Not unless you build a time machine during quarantine. If you build a time machine during quarantine, then I guess maybe. But barring that, no, you can't get home in a negative time. Can you drive home at a negative speed? No, that's not a thing either. So we're not going to need any negatives. Then ask yourself, could zeros be possible? Can you get home in 0 time? No. So do not try to touch this axis. Because if we were getting home in 0 time, we would be like here. This would be representing for us no time has passed. If I'm high, that means that time is
Down.
If I'm up here on the graph, that's a measurement of time being high. If I'm here, time is kind of like medium. If I'm here, time is low. If I touch this, time is at 0, and that's not going to be a thing. We are not going to touch this line. Then think about speed. Could you get home at 0 speed? No. So don't touch this line either. If I'm working in this area, that means that the speed is big, middle, or little?
Big.
Big speed. When we go far to the right, because that's the speed axis going this way, this is like super fast stuff. This would be middle fast.
Little.
Not very fast. This would be literally no speed. So I'm not going to touch this, and I'm not going to touch that. That would be sort of like my first consideration. Question on that. Then try to think like some sort of correlation and have a sentence. You'd have a few correct ways you could say this. If one of them is high or low, it makes the other one be high or low. Just think of one of those options. There's multiple options about how that could be. What's one relationship about the highness or lowness of time versus speed?
If you go fast, like higher, then your time will go down.
Okay, so a higher speed is going to create a lower time. So out of area A, B, C, or D, which of those areas would be representative of, what did you just say?
If you go a higher speed, then lower time.
Okay, so a high speed, low time zone. Where is a high speed but low time zone?
See?
Agree. So like just put a dot in there as a marker to remind us of that. If we go a high speed, we're going to go a low time, so we're there-ish. Then make up another like thought process on that, other than that one.
If you take a lot of time, your speed is probably not that great.
Okay, so a low speed goes with
High time.
high time. Where is that?
That would be A.
Agree. Anything low, since this is the speed axis, anything low speed is left. High time, since that's the time axis going this way, that would be high. So I'll do a little dot there as a marker. I'm going to erase the A, B, C, D because just didn't want that to be a part of my permanent life. So we have something like that. Now, if I put this dot here, is that really a radical difference?
No.
Not really. Okay, but if I had this dot over there,
Yes.
that's a problem because now I have, this is no longer a, which one? No longer high speed, that's now
Low
a
speed.
low speed. So that doesn't work for me over there. So you have some wiggle room, okay, but you don't have like total freedom to just do whatever you want. Then we want to like play connect the dots. If you went like this is wrong. It's pretty good, but that's wrong. What's wrong about that based on the decision we already previously made? Yeah, ultimately, if we kept drawing, it would go negative in both directions. What else would it do in both directions that we already decided against?
Just the other one.
Touching the other lines. We had already decided zeros were not in play, so we were not touching those. So these would not be connectable with a straight line because that would violate what we have. So can anybody figure out some other shapy kind of thing that could get us from here to there? If it continued forever, it would never touch the lines. Can anybody shape that? Circle would kind of like end up taking us through some zones that we don't want to go. Because like we don't want to go here. So like if we tried to go circle, we'd end up entering the two places we don't want to enter. If I did the grid back again, this and that were both sort of like no-go zones. So, well, but we have to allow it to, if we're trying to make predictions, we have to allow it to stray beyond what we originally chose. We're trying to guesstimate what would happen, you know, as we got closer, and as we got lower, we want to have a feel for what that might do. Can anybody shape, getting me from here to there, but never touching either line? How about them apples? Okay, so you might tonight on these stories hit a wall to some degree, and then you just move on to the next story. That's okay. Okay? But this has to come down. I mean, we could think through. As the speed goes up, the time has to come down. So we are wanting to come down as we go right, and we need to go up as we go left. But to avoid the touch, it's got to have a bend in it. And maybe you'll figure that out, maybe you won't. But if all you did is write time and speed and have a couple dots, then we can talk about it tomorrow. Let's put the finishing touches, that's fine. I would not spend, there's like 10 of these. I don't think you should spend more than like 5 minutes on one of them. So if you're at the 5-minute mark, just bail and get out of there. That's 50 minutes of homework. That's plenty. It's not. I'm not trying to ruin your entire life. Question about concept there. So some of the stories, they might just tell you something like you're going to go out and ride on a seesaw. In case you haven't done that for a long time or know what I mean, like one of those deals where two friends sit on each end and we're going ups and we're going downs. So as you do that, something's changing. What's changing as you ride a seesaw?
That's one goes up, the other goes down.
That's true. What's a thing that we could measure? Like you're driving home from school, we can measure the time it takes you. We can measure the speed that you're driving. That's the two numbers we're keeping track of. On this, what's like anything we could be trying to keep track of?
The child.
The height depends on the weight.
Okay, so let's say the height above the ground. And I think they'll say the sentences this way every time with the word depends in it. We'll just finish this trig story and then we'll get to our calculus friends in a minute. The height above the ground depends on time is always in effect. So time may just be a thing. So if I'm going to do this picture, I'm going to go height, because that's independent. Depends on, or is dependent, excuse me. Time is the independent. And then I'd think through, can I have a negative height above the ground? Generally that answer will be no. For the negatives, your seesaw is not going to burrow underground. Can I have a negative time? Again, no. Time machines, not a thing, I don't think, not yet. Then I'd think about the zeros. Can my seesaw have a 0 height above the ground? You might be tempted to say yes on that, but if I had more time, I'd eventually tease it out of you, but we're in a little bit of a hurry, and I'm going to just say no. You don't want your seesaw to height of 0 above the ground. That means you hit the ground. And if you're doing polite seesaw riding, you shouldn't hit the ground. You usually only hit the ground on the seesaw when your friend got off to be a jerk and you crashed and bounced, okay? So we don't want to do 0 height, so we don't want to touch that. But we can think about when you get on the seesaw, are you a tall height, a middle height, a low height? Where are you when you mount the seesaw?
Low.
Disagree, because if one of you is low, the other one's high. So if you're getting on low, you're making your friend like catapult themselves up on there. How do you mount it?
Medium.
Both medium. So I would do a dot here. Some of the stories are going to be kind of like a process where there's like a moment where somebody in charge of measurement would have to say, okay, let's get on the seesaw. Are we ready to start the process? Go. Driving home isn't really like that. But if we're going to have a seesaw measurement party and somebody's trying to measure the height above the ground, they're going to be like, wait, 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 don't start riding the seesaw yet. Let me get my gear ready. Get on the seesaw, everybody. Okay, are we ready? Okay, let's go. And then the seesaw would start to be ridden. Should I go up or down? Trick question.
Both.
Yeah, it really
Doesn't matter.
doesn't matter because one person is going up while the other one goes down. So you just pick a direction. One person's height might rise. Will it rise forever? No. How's this shape going to be? So it's going to go like up and down and up and down and up and down and up and down. And you could do that until you got really pretty bored. But you would not touch this line because we previously discussed that. What would it mean about hitting this line? You'd be on
You
the
hit the
ground.
ground.
You'd hit the ground. That's a 0 height line, and we don't want to hit the ground while we ride our seesaw. So to use our word from before, is either of these periodic? This one, because this one
Repeat.
repeats. That's not periodic, nothing repeated there. You went home. Nothing happened twice. Okay, so that's the deal on these. We're on page 6. Just doing your best to try to make these little like sketch graphs. There is no one perfect graph for this. Some are more frustrating than others. If you get a frustrating one, move to the next one. If you start to do one and you're like, I don't have a clue on this one, just immediately skip to the next one. But I do ask that you double back and at least try to get yourself with the axes drawn, the words chosen, and begin to think like, should I be touching these lines or not? So, that's it.